Okay, take a minute, go to your course space and make sure you see quiz 7. Okay, make sure it says 9:35, right? Or okay, cool. So yeah, knowing it's your midterm, I also graded your written homework already, if you didn't check it already. So the midterm is on Friday. So do you want me to do the same thing as last time? Like make Thursday like just office hours for questions, like last minute questions for the midterm. Is that good with everyone? Or okay, cool. So you could come if you have questions. I mean, or if you just know everything already, you don't have to come. Okay. So I guess the weird thing is we're moving on to chapter 11. So it seems awkward that we're skipping, you know, and like it looks like a completely new topic. So let me sort of tell you why we're doing this. Yeah. So integrals in general are hard. Even with all the rules you've learned, right? Partial fractions, trig sub, trig integrals, u sub, integration by parts. Like a lot of integrals are still like, hard to do by hand. Like so instead we give up a bit and we say, okay, instead of knowing the exact value of the integral, instead, can we ask, do we know if it's a finite number or not? So forget what number it is, right? We're all suppose all we care about is it finite? Yeah. Does it how do I say it? Does it diverge, right? Is the integral actually infinite, right? Like for example, if you graph 1/x, right? If I say from 0 to 1, like I don't know, you would have to ask. If anyone can answer that, please do. So right, this thing has infinite, sort of looks like infinite, right? So is it actually infinite, right? From 0 to 1. Like so to solve that, if we recall that integral is just this summation, right? Of this like right Riemann sum, if you remember, like limit n goes to infinity of this thing, or if you like, it's goes to infinity. Do you remember this? Like back when we did like Riemann sums. So basically the rest of 2B is devoted to studying these summations, and you'll learn a lot of rules to figure out if these summations converge or diverge, right? And converge would mean you go to a particular number. Diverge will mean you don't, right? Because if you think about it, like if I just write this, it's possible it goes out to infinity, right? I mean, it's 1 to infinity. So I'm adding infinitely many terms, right? It's entirely possible this thing like, just blows up, right? So, and the first step is this thing, this series. So it'd be like, or series, it's a type of sequence. Yeah. So that's why we're learning sequence today. We're gonna learn sequence today and then series next time, and then we learn like maybe not next time, like next week. And then like, we'll learn tests for these. So is everyone clear on like what's happening? Hopefully that bridges the gap from like chapter 7 to like 11. Okay. So sequence, let's define it. Sequence is a list of numbers written in an order. Yeah. So we would say like A1, A2, A3. This is an order, right? So the 1 denotes like first term. The 2 denotes second term. Yeah. And then like if you prefer functions, you can think of sequence as a function on natural numbers. Yeah. So the function is clear, right? The function f, where do we send this natural number to real? Sorry, I guess you don't know the notation for real number. Real numbers, right? So we send n to an. Hopefully that's clear. So you could think of it this way. It's a function on natural numbers. It takes n to an. So some books, let me just write some books. If they're vague, write sequence as like an. If they're more clear, they'll tell you like the starting point and ending point. But if they don't tell you, assume it starts at 1, right? And goes on. Yeah. So an example would be like, these are all the same, right? This thing, an is 1/3 to the n. So again, if you think of it as a function, right? The function takes n to 1/3 to the n. So if you want to think of it as a function of naturals, or you could just write it out, right? When n is 1, it's 1/3. When n is 2, it's 1/9, or 1/3 cubed, and then 1/3 squared. And then when n is 3, it's 1/3 cubed, so 1/27, so on and so forth, right? Everyone clear on this? Pretty basic. So with this, you can ask, right? This thing goes on forever, right? Sort of like it's ... So you can ask, does it go to something as you go on forever, right? So we have a notion of a limit. Do these lists of numbers approach something? Yeah, so that's what you should ask. And if it does, if it approaches a number, then we call that L. Yeah. So you read this as sequence an approaches L as n becomes large. Okay, n becomes large. Right, so why n becomes large? Well, n was this index, right? N denotes this, right? So what does it mean to go far out into the sequence? It just means n is larger and larger, right? Because like at some point this is like what, A100, and at some point it's A1,000,000. Yeah. So the n gets larger and larger. So n larger and larger means you're going farther and farther down into your sequence, right? So definition, we say if limit n goes to infinity an exists. So in other words, it's a number L. We say sequence converges. And if not, we say sequence diverges. So let me just say, if sequence converges, right? So math 2A rules apply to, I don't want to write it all out, right? To convergent sequences. Right, so everything you learned, like, addition law, right? Like sum of two limits is limits of sum, right? Like, and then, stuff like squeeze theorem, these hold, yeah? Like L'Hopital rule, like all the stuff you learn in Math 2A holds for like convergent sequences. Okay, let's start off easy. Let's do tons of examples today. Let's start off, easy to hard. What is this? So again, for people who don't like, I'm writing it as a function, right? It's a function that is the function on natural numbers given by 1 over n. If you don't like, if you like sequences more, this is just a sequence 1, 1/2, 1/3, 1/4, 1/5. And then I'm asking, where does it go to? Oh shoot, I just wrote the answer. Okay, that was my mistake. But it goes to 0, right? Because as you go farther and farther down, like when you go, the n gets larger and larger. And if you have a larger and larger denominator, right, the number becomes smaller and smaller, right? It goes to 0. All right, what about this? What is this equal to? So again, if you don't like functions, you could think of this as the sequence 1, 2, 3, 4, 5, 6, so on and so forth. So this converges. What about this? Yeah, it diverges, right? In fact, you actually know where this goes off to. It goes off to infinity. I mean, you're getting larger and larger, right? Okay, what about this? So write out the first few terms, try that. So what is this? So when n is 1, what do I get? So n is 1. And n is 2. What is it? Good. N is 3. I'll stop at 3 because you should see the pattern by then. What is -1 cubed? Okay, so what's the pattern? Like, do you see the pattern? Hopefully by now you see the pattern. So okay, so it keeps oscillating between -1 and 1. So what do you think this limit is? Can you approach something? Can you approach a number if the sequence just keeps going between -1 and 1? Is it possible? I mean, it can't approach anything, right? Because like you're going between -1 and 1, right? Like it is not possible to approach a certain number if you're always oscillating between two different numbers, right? Hopefully that's clear. All right, let's do something like this. So forget the square root. What about n plus 2? Does it go to infinity? N plus 2 clearly goes to infinity, right? When n goes to infinity. So what do you think square root does? Like if something goes to infinity, square root of that something should still go to infinity, right? Like, I mean, sure, it goes to infinity at a slower rate because you're square rooting, but square root of x, right? Like square root of x, right? Looks like this, right? Like you're going to infinity slower, but you're still going to infinity, right? Like, so this thing should be infinity, right? In which case it diverges. Okay, what about this? This you should know. Just think it through. Obviously, the 2 has no effect. So the question is really, what happens to this term? Exactly. And this will hold in general for any number between -1 and 1, right? Because if you think about it, just think of the easy one, like a half. If I keep raising a half to a certain power, what do I get? A half squared is a fourth. A half cubed is 1/8. A half to the fourth is 1/16. You see, it gets smaller and smaller. Agree? So this thing should go to 0, right? As you raise numbers between -1 and 1. Obviously, if you raise numbers bigger than 1, it's gonna blow up, right? Like 2 to the n goes to infinity, right? So this thing is 2, so it converges. Okay. These are very common. I've seen these a lot on like midterms, so you should understand this. Uh, what about this? So I'm saying this is the same as the previous one. So we just need to manipulate it a bit. So if you're unsure, maybe manipulate it a bit. So this, you get this. And now you have this. What is this? It's the same logic as the 0.86 to the n. What is this limit? So again, you have a number between -1 and 1. You're raising it to the power n. It should get smaller and smaller. Same idea as this 0.86. because 3/7 is between -1 and 1. So where should this go to? Good, good. 0, right? I'm gonna make it harder and harder. Limit n goes to infinity cosine of pi n. I'm sorry. If all of you do not like functions, this is the, see, when n is 1, it's √3. When n is 2, it's √4. When n is 3, it's √5. And then, so this is the sequence you're considering, right? And then if you don't like functions, I mean, so this is the sequence here. Whoa. This is the sequence you're considering, so on and so forth, right? Okay, so now what about cosine of pi n? So if you are unsure, again, my first suggestion, same exact thing as this, right? If you're unsure, just, it doesn't hurt to just write out the first few terms, right? Maybe you'll get something. So let's write it out. When n is 1, I get cosine of pi. What is cosine of pi? Cosine of pi. -1. Okay, when n is 2, I get cosine of 2 pi. What is that? Good. No, okay. Take it back. No, it's not 0. Yeah, good, good. And then hopefully you see the pattern, right? It's the exact same as this. This is just a hidden -1 to the n. Yeah. So be aware on your midterm. If you see like a cosine of pi n, you should immediately think like -1 to the n. But again, rule of advice, test out the first few terms, right? If you're unsure what type of sequence this is. And we just showed that does not exist. Okay. Moving on. So I want to clarify something. Now, if I go to an actual function, right? So this is like math 2a now. What is this limit? So I'm no longer doing a sequence. This is like an actual function. X goes to infinity, sine of pi x. What is this limit? So if I graph sine of pi x, the pi x maybe like shortens it a bit, but it's still a wave, right? I mean, it still looks like this, right? So when x goes to infinity, where does this go to? Yeah, it diverges, right? Because I mean, it keeps oscillating, right? Okay. Now I want you to note the difference here. Okay. So I'll stop graphing this first. So I'm claiming this thing does not exist. This thing's 0. Yeah. So the graph of this, remember, we only care about n equals 1, n equals 2, n equals 3, right? So when n is 1, that's sine of pi. Sine of pi is 0. N is 2, sine of 2 pi is 0. Sine of 3 pi is 0. So this is the graph, right? So it's part of this graph, right? It's like the these parts, if you like. Yeah. So that's the one thing I need you all to get clear in your head. A sequence is on natural numbers, right? Like there is no a 1.5. There's no a pi, right? You only have like 1, 2, 3, 4, 5, 6. You know, your inputs are like natural numbers, right? It's not any real number. So it's not continuous like this, right? If you like, it's sort of like discrete. Is everyone clear on the difference here? It's pretty important. So but it is true, right? If as a function it converges, then as a sequence it will converge. But the opposite is not true, right? If this thing diverges, it's still possible. As a sequence, it converges. Yeah. Okay. Now that that's clear. I'm gonna ask this. What do you think this is? N goes to infinity. So the one thing I don't want you all to also think is if once you see -1 to the n, you think oscillate and then you're done. It diverges because this thing is 0. Yeah, you have to really think about what this sequence is, right? So let's if this was alone, the graph of this would be like this, right? At 1 it's -1, at 2 it's 1. Yeah. Right, at 3 it's -1, at 4 it's 1. That's the graph, right? So this thing is still oscillating. So what do you mean by oscillating? It means I'm at one point I'm above x-axis, at another point I'm below, right? So I'm still like this, right? But so here's my question. If at one point I am above x-axis and then next point below, right? What's the only chance that I converge? If at this point I'm above, then I'm below, then I'm above, then I'm below, then I'm above, then I'm below. What's the only possible way this thing's gonna converge? Where must I go to, picture-wise? So I'll give you a hint. I'll draw it for you. Like I have to go somewhere, right, for it to converge. So where is that? Can anyone tell me? I gave you a hint here. So what is that? Yeah, you have to go to the boundary, right? You're bouncing like up above x-axis, below x. So you have to go to the x-axis, right? And that's 0. So that's the thing here. Yeah, so you have a theorem in your book. I didn't want to give it to you because I wanted you to understand the idea first, but you could use this if you think it converges. If absolute value of an is 0, then limit n goes to infinity, an is 0. So here, like limit n goes to infinity, absolute value of -1 to the n over n. This thing is 0 because what happens when you absolute value -1 to the n? It just becomes 1, right? In which case you get this. So if you apply the theorem, you get it 0. But the idea of this is so this absolute value thing being 0 means you go to 0 from both sides, right? So from above you go to 0, below you go to 0. Hence you must go to 0. So that's the idea here. Okay. So I just want to remind you of L'Hopital, right? Limit n goes to infinity, n squared over e to the n. So again, I told you, right? If you consider as a function and it converges, then it will converge as a sequence. So here, right? You learn this. If you get infinity over infinity, you could L'Hopital, right? L'Hopital just means derivative of top and then derivative of bottom. And then same thing. You get infinity over infinity, you L'Hopital again, and then you get this. And you know this is 0 and this is 0. So let me just say in general, this thing, let me just write it like here. This thing is like a polynomial, right? This thing is exponential. Yeah. And in general, polynomials grow slow compared to exponential. That's why exponential growth is considered like fast, right? I mean, that's how like bacteria and stuff multiply. It's super fast, right? So, so since this one's super fast, this thing's way larger than this. And if you think about it, if you divide a number by something that's way larger, you get a really small number, right? So you should expect 0. So yeah, this is just reminding you of L'Hopital rule. Let's just do one more. This might come up, so I'll give you some tips. If you see natural log, right, you want to maybe simplify this, because if I plug it in, if I just plug in n equals infinity, I get infinity minus infinity, right? So that's undefined, right? So what do I do? Well, my suggestion is always combine it. So how do I combine a difference of two natural logs? What can I do? So use the natural log rule. Divide, good. And if you just write this out, like it becomes clear, right? This is just 1 plus 1 over n. So when n goes to infinity, this thing goes to 0. So this thing goes to the natural log of 1, which is 0. Yeah. Everyone clear? So I mean that this should cover most of the sequence problems you'll see. I mean they're not going to be exactly the same, but hopefully you get the idea on how to do these. It should be pretty simple. Things will get really hard when you go to series, but for now it shouldn't be too bad.